Hello, and welcome back to our Introduction to the C programming language. This is session number 8 of 10. A quick recap from last time, we went over basic formatted I.O., character set encoding, and the various file I.O. functions in the C standard library. This time we'll be going over debugging your programs. So, first and foremost, what are bugs? Anytime you have unintended behavior in your program, that's a bug. They can come from any kind of mistakes in your logic or just mistyping something. I know I've forgotten to call functions before, and that's led to bad output. There are as many different sources of bugs as there are ways to program something incorrectly. Programmers aren't perfect, so bugs are going to crop up no matter what eventually, especially in more complex projects. So how do we track down where these bugs are, and how do we eliminate them from our code when we do find them? The easiest way to do it in C is just to use the printf function, honestly. You can have printf print out the current value of a variable as you run through your code, and that can often give you just enough information to tell you where something has gone wrong. Placing these regularly in sections of your code that seem to be having problems can be helpful to finding out what data is being corrupted or what's just being used wrong. And it doesn't require any extra tools. However, printf can't slow your program down for you like more robust debugging software can. And if you're not careful with it, having too many printf statements in your program will make it so that your terminal output is very, very flooded. And it can be pretty difficult to keep track of what's what if you use it too much. So if printf debugging isn't going to work for you, what about debuggers? Debuggers are tools that are used to slow down execution of another program, and typically they'll let you see the source code of that program too if it's available. Typically this is done so the programmer can watch as the program executes. Normally, you know this, your code goes too fast for you to be able to tell what's going on in any given microsecond. So debuggers will let you slow down and run through your code line by line, and sometimes it'll let you tinker with it while it's running. Set variables to certain values, tell it when to skip over certain bits of code, etc. Modern debuggers, including ones built into Microsoft's Visual Studio, there are debuggers included in a lot of modern IDEs, or they'll hook into other debuggers, or if you're working on a terminal in a Unix-like system, the GNU debugger, or a spin-off called CGDB. These will all let you see the source code of your program as it's running, set breakpoints in the middle of your code, let you speed through the code you don't care about, watch variables in memory, among so many other things. Getting into the details of specifically how to use these tools is a bit outside of the scope of this because each of them operates a bit differently. In my opinion, GDB and CGDB are the most powerful options, and gdbtutorial.com that I've linked here it's a pretty good tutorial to get you up and running with it. What these kinds of debuggers are is something called a symbolic debugger. In non-symbolic debuggers, you'll usually just end up seeing the assembly code, which isn't particularly helpful for figuring out what's going wrong in the code you wrote, as opposed to the code the compiler made for you. And this, because we tend to think in terms of our own source code, being able to see the code as it's running is the preferred way of debugging it. In order for a symbolic debugger to be able to see the source code of your program, it needs to be compiled with the debugging information built in. In Visual Studio, this is basically always the case until you make a full release build. Even in release mode, if at the top of a Visual Studio window next to the little green play button, there is a drop down to switch between debug and release mode. Even in release mode, you still have the debugging symbols compiled in. On GCC, you need to add the -G flag to your command line. Many IDEs will have tools that will do this for you. So if you're using something like Code Blocks or Eclipse, that probably has a plugin or built-in functionality to hook into the debugger for you. So a lot easier than telling you how to use debuggers is telling you how not to use them. Don't just step through your entire program one line at a time. Think about where things are actually going wrong in your code. Let it run normally until you get to the point where you actually need to see what's happening, and then slow down and watch things closely. This will save you a lot of time, and a lot of repetitive stress injuries from hitting the button over and over. Use the ability to watch variables. More helpful than just watching your code run one line at a time is the ability to query the value of any variable that's in scope. And a lot of debuggers will even let you modify those variables while the code is running. If something weird's happening, take the time to understand exactly what values are being held in memory, and that will probably give you a hint as to what's going wrong. Don't run your program start to finish if you don't have to. A lot of debuggers will let you set the next line of code that you need to execute. So if you're walking through your code one line at a time and happen to pass the section that's giving you trouble, and if you haven't solved the problem yet, you can tell the debugger to either start over if that's what you need, or just run through that bit again with the set next statement function. When you're using a debugger, turn off compiler optimizations. So that would be flags like -O2 or -O3 in GCC, and in Visual Studio that would be release mode. Compiler optimizations under the hood can make pretty drastic changes to your code, to the point of even like doing things out of order, or doing something called unrolling loops, where instead of actually going through a full loop, the compiler will see that you only do this 2 or 3 times, so just copy paste the code to do it 2 or 3 times. And because of these differences can compound, and if your compiler optimization is particularly aggressive, what you're seeing in the debugger may not actually be what code is running. So you do want to turn those off. Turn them back on once you've solved the logic error. If your logic is right, turning on the optimizations shouldn't change the output at all. And lastly, and most importantly, the debugger can't think for you. It just shows you some things you wouldn't otherwise be able to see. The most effective debugging tool is always careful thought. So once you've seen where the code goes wrong, how do you fix it? Like with that last point, careful thought is the best way to do this. Just think very carefully about what your code actually needs to do where the bug occurs, and contrast that with what's actually occurring. Sometimes the fix will be pretty obvious, especially for smaller ones like just forgetting to call a function. I know I do that a lot. But sometimes it can be trickier. The worst bug I've ever had to track down took me like a week to fix. And I know there are a lot longer ones for people who have more experience in the industry than me. Break down your problem into simple steps and then write your code. It's the measure twice, cut once of programming. This was a pretty short one, in part because I can't go into detail about the various tools available, because each tool is going to be very different from the others. But we have gone over some quick principles about debugging and had a quick intro into debugging software. Next time, we'll be going over operators and expressions. We've been using those this whole time, but we're going to be going into detail about them. As always, there are live sessions for C and C++, as well as general software design and engineering available on the site. Thank you for joining us.